In this video, I'm going to talk about secant and cosecant graphs. So we'll talk about the parent functions first, and then the steps for doing cosecant and secant graphs when we have transformations. We have the parent functions are y equals cosecant of x and y equals secant of x. For cosecant of x, another way that I can write that in terms of what I've talked a lot about is I can write that in terms of sine. So instead of writing cosecant of x, I can write 1 over sine of x, and that's going to help me understand what the graph is going to look like. So the first thing that I want to note, like when we were looking at the tangent fraction broken down into sine and cosine, we saw that we had something in the numerator that when we plugged in some x value, we could get 0 in the numerator. Here, there is no x value that I could plug in that I could make the numerator equal to 0. So for cosecant graphs, we are going to have no x-intercepts. There are no x-intercepts because there's no way for me to make this one equal to 0. So there's nothing for me there to plug in to make that numerator 0. So there's no x-intercepts. The other thing that we can note is that I have sine of x in the denominator, which means that when sine of x is equal to 0, I'm going to have vertical asymptotes. So if sine of x is equal to 0, I know I'm going to have vertical asymptotes, a vertical asymptote at x. And I know the x values that would make sine of x equal to 0 are 0, plus or minus pi, we just talked about this, plus or minus 2 pi, etc. So every pi starting at 0. And so these are going to be my vertical asymptotes. So I'll also have vertical asymptotes for sine, or for cosecant and for secant graphs. I'm going to draw these in. I'm going to scale my graph. I'm going to do counting by pi over 2 again. So pi over 2, pi, 3 pi over 2, 2 pi, and then 5 pi over 2. And then I'll do the backwards version, so negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, and negative 5 pi over 2. Okay, and then I scale my y-axis, so I'm going to scale by, I'm going to count every 2 as 1, and then I'm going to start putting these vertical asymptotes in. So I have a vertical asymptote at 0, so I'm going to draw that in here. I have one at pi. I have one at 2 pi. And then going backwards, I have at negative pi. And I have at negative 2 pi. So I'm going to draw these in first. In order to draw cosecant or secant graphs, I'm actually going to draw its reciprocal and use it to find what the cosecant or secant graph is. So the reciprocal of cosecant is sine, which means on a normal, on the parent function for sine, I know I start at the origin. So I start at the origin, and then I'm going up 1, and then back to the middle, down 1, and back to the middle, up 1, and back to the middle. And then I can repeat that pattern backwards. So I'm going to draw in sine. I'm just going to draw in sine. It's not going to stay on the graph. I'm just going to draw it to help me draw the actual cosecant graph that I need to draw. So it's just there. It means nothing. I didn't put it in red. I should be erasing it or getting rid of it or showing that it doesn't belong on the graph. I'm just using it as a guide. Then on the maximums and the minimums, I'm going to have points. So on the maximums and the minimums of this sine graph that I drew, I'm going to have points. Inside of each vertical asymptote, or in between 2 vertical asymptotes, I will be going, as I go to the left, I'm going to get closer and closer to 1. As I go to the right, I'm going to get closer and closer to the other. I should be drawing parabolas on top and on the bottom of the sine graph. So they should not be intersecting. So I should not intersect. I should not be drawing it this way. I should not be drawing it this way. I should always be drawing it so that they don't intersect. And so I should be drawing a little parabola here. And I should be drawing a little parabola here. and I should be drawing one here and one here. And if there is a vertical asymptote there, I could just draw half of it. I don't know. I'll just draw the whole thing. So this is what my cosecant parent function would look like. For secant, I know that I can rewrite that as y is equal to 1 over cosine of x, which means still no x-intercepts. Notice I did not, and that's another reason why I know that I'm not going to be drawing this downwards, because then I would have x-intercepts. So I should be drawing it away from the x-axis. So I have no x-intercepts. And I also know that cosine of x, when that's equal to 0, that's where I'm going to have vertical asymptotes. So I know that's going to be for values plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, etc. So these are where I'm going to have my vertical asymptotes, and I know I do not have any x-intercepts. No x-intercepts for these graphs. Okay. I'm going to draw in my vertical asymptotes. I should have just had this scaled already for you so that you didn't have to put it in, but I'm going to scale by pi over 2. Pi over 2, and negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, and negative 5 pi over 2. Okay, and then I'm going to put in the vertical asymptotes. So I'm going to have a vertical asymptote at pi over 2. I'm going to have one at 3 pi over 2. I'm going to have one at 5 pi over 2. And negative pi over 2. And negative 3 pi over 2. And negative 5 pi over 2. And those are my vertical asymptotes. And then I'm going to draw my cosine graph. So I'm going to draw a cosine graph, which starts at, I have to scale this. So this is 1, 2, 3, negative 1, negative 2, negative 3. So I know I start at the maximum, I go to the middle, then down to the minimum, then to the middle, up to the maximum, to the middle. And I'm going to continue this pattern backwards. And then I'm going to just draw this curve. I actually don't even need to draw the curve. I see where my maximums and minimums are. I see where they're in between the vertical asymptotes. I have a parabola here. I have a parabola here. Remember, it should not intersect with the x-axis at all, or your new x-axis if you are if you have a vertical shift. This is what my secant parent function looks like. So those are what they look like. They should be just a bunch of parabolas in between vertical asymptotes. The steps for doing transformations with secant and cosecant graphs to graph them, the first thing you're going to do is you're going to graph sine or cosine, depending on what you have, with the same transformations. So with the same transformations that you see. A period is going to be equal to 2 pi over b for that. It will be just like you would always draw the sine or cosine graph. So the sine or cosine graph, you're going to draw it based on the transformations that you see in your secant or cosecant equation. Then the next thing you're going to do is you're going to draw vertical asymptotes through the middle points. So notice that in both of these graphs, let's look at where the vertical asymptotes are. I guess we can use green. I'm going through the middle of the sine graph. Here, I'm going through the middle of the, I didn't draw the whole thing, but I'm going through the middle of the cosine graph for where those vertical asymptotes are. And then the third thing I'm going to do is I'm going to draw parabolas on the maxes and minimums of sine or cosine, making sure I don't go, I draw them away from the x-axis. So I'm going to draw parabolas. On the maxes and the minimums of sine or cosine. And then the last thing that I'm going to do is I'm going to erase the sine or cosine graph, or indicate in some way, shape, or form that it is not included. I'm going to leave only the parabolas. Okay. I think the best way to do it is to not actually draw it like I did here. Just draw the maxes and the minimums and the middle points so you don't mess up, so that you don't have to erase it. All right, let's try an example. So I have example 3 here. I have, let's see, is this what I left for you? Yeah, okay. So I want to look at the transformations that I have. Well, I have, first of all, amplitude of 1, which I need to know, so I'm going to write that down. I have a 2. 2 is B, or B is 2. And so I know that period is equal to 2 pi over B, which is 2 pi over 2 here. So the period is equal to pi for this graph. And then I know that I'm also, another thing that I have is that I'm going, oh, stupid thing. I'm going up 2. So I see that I'm going to be going up 2, which is important because that means my new x-axis is at y equals 2. Okay. The other thing I need is to know what I'm counting by. So if I have a period is pi, I want to count by 1/4 of that. So I'm going to do pi divided by 4. I know then the scale is going to be pi over 4, then 2 pi over 4, which is pi over 2, then 3 pi over 4, which does not simplify, then 4 pi over 4, which simplifies to pi, and then 5 pi over 4, which does not simplify. So that's my scale, and I'm going to put that on the graph to start. So I don't know if I even wrote that in the directions, but you need to scale your axes before doing anything else. I mean, those are the rules for graphing sine and cosine, which is what I said was the first step. All right, and then after I do that, I need to make sure I'm scaling this axis as well. Do I want to make it? Yeah. Like this and like this. Okay. And then what I'm going to do is I'm going to, oopsies. I'm going to plot, or put in the sine. I'm going to draw the sine or cosine graph. And in order to do that, I need to draw my new x-axis. So my new x-axis is going to be at y equals 2. I'm going to put that in like this, blah, blah. And then I'm going to, so I don't have a new y-axis. I had no horizontal shift. So I'm going to start with, a point, and I'm going to do it in black right here. That is the start of my, this should be sine is the reciprocal. So I should be drawing a sine graph. So at pi over 4, I should be going to the maximum because it's positive, and then middle, then minimum, then middle, then maximum, then middle, and then here I'd be going at the minimum, middle, max, middle, min, and then here in the middle. I'm going to be drawing the vertical asymptotes through the middle points. That's not a middle point. Through the middle points is my next step, to draw the vertical asymptotes through the middle points. And through here, through here, through here, and through here. And then I'm going to draw my parabolas. So I should not be, what'd I do? Oh wait, I shouldn't have. Oh, I guess I do have, sorry, I do have x-intercepts. I'm not supposed to be going through the new x-axis. So I can have x-intercepts on the actual graph. I just can't be going through the new x-axis. So this is how I'm going to draw my parabolas. And that's what that graph looks like. And then let's do example 4. So I see that I have an amplitude equal to 2. That's important. I'm shifting to the right 1/2. Oh, I should have said what my b is first. My b is pi. So if b is equal to pi, then period is equal to 2 pi divided by b, which is pi, which means that the period is equal to 2. So that's something I need to know for scaling my graph. I know because of the minus 1/2 inside, this means I'm moving right 1/2. And then because of this minus 1, I know that I am going, everything's going down 1. the right 1/2 means the new y-axis is at x equals 1/2. And for going down 1, the new x-axis should be at y equals -1. First thing I'm going to do is, what is my scale? So I know I'm going to be counting by 2 divided by 4, or 1/2. And so the scale is going to be 1/2, and then 2 over 2, which is 1, and then 3 over 2, I'm going to leave it as that, and then 4 over 2, which is 2, and then 5 over 2, and I only have that on the graph. So this is 1/2, 1, 3 over 2, 2, 5 over 2, and backwards, -1/2, -1, -3 over 2, -2, -5 over 2, and then 1, 2, 3, -1, -2, and -3. And then I'm going to put my new y-axis at 2. So this is my new y-axis. Boop. I'm going to put my new x-axis at -1, so right here. And then I'm going to put the graph. So I'm starting at this is secant, so the reciprocal is cosine. So I'm starting at the max. So I should be at, instead of negative, I should be going up 2. So this is actually a distance of 2. That's my amplitude. It's positive, so I know I'm starting at the max, not the minimum. Go away. And then the middle, I'm going to be at 1, and then 3/2, I'm going to be down 2. The middle, then up 2, or at the max, I'm going backwards. I should be here, and here, and here, and here, and here, and here. Did I do this right? Does it look right? It looks right. And then I'm going to drop my vertical asymptotes in the middle, so don't be confused. That your new y-axis is not a vertical asymptote. So I'm going to draw the vertical asymptotes in the middle, that's here, in the middle here, in the middle here. And then I'm going to draw the parabolas. So I should have a parabola here, a parabola here, a parabola here, and here, and here, and here. And I don't see the other vertical asymptote, but I know it's there. All right, and that's it.